All right, two more, and these ones are kind of neat, some application. It says, an amusement park ride includes a free fall drop of 272 feet. You can use the equation d equals 16t squared to determine the time t in seconds that it takes a dropped object to fall a distance of d feet. How long does the free fall part of the ride take? So this formula they're giving us, d stands for distance, 16t squared, t stands for time. This is a very common physics formula involving gravity, portion of it. Now this ride is very similar to the Pitfall at Kennywood. You may have been on it, where they take you up to the very top and then click, 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 and you drop. So same thing here. Now this is the formula. We want to know how long, if the ride is 272 feet high, how long are we actually, from the time we are at the top till we drop, how long does that take? So I'm going to substitute in 272 for the distance, equals 16t squared. First thing I'm going to do is divide by 16. Now you might say, wait a minute, I thought you said there's a square, you take the square root. That's right, but you can't do that until the very end when it's just your variable, like t squared. First thing you have to do is get rid of everything else. So you have to clear things out. So that's what we're going to do here. So 272 divided by 16 is 17. So that's gone. Now I have 17 is equal to t squared. And this is the point where I go ahead now to get my t by itself. I take the square root of both sides. The square root of 17 rounded. Does it say? Takes a dropped object to fall. How long does it take? The free fall part of the ride. They don't ask us to round it, so we will round it to the nearest tenth. For procedure, we get 4.1 seconds. We want to label it because it is a word problem. Okay, I don't think it says anywhere. I might be missing that. Nope. So 4.1 seconds. You are from 272 feet, which is almost a football field long, all the way to the bottom in basically no time at all. All right, example 5, you try. Same concept. This construction worker building a skyscraper accidentally drops a bolt from a height of 500 feet. Use the equation d equals 16t squared to determine the time in seconds that it takes a bolt to fall to the ground. They actually checked on Mythbusters if dropping something from the Empire State Building would, they say if you drop a penny, it would do severe damage to the person it would land on if it were to land on somebody. But I think Mythbusters found there's ledges and things like that that would come into play, so it's not going to happen. So feel safe, we're not in danger. The first thing in this problem, I went ahead and I substituted in 500 for d, the distance. 500 equals 16t squared. I want to get t by itself, so I'm going to first divide everything by 16. 500 divided by 16 is 3.125. Now they don't say anything about rounding. If it's a number, there's some different concepts as far as how this goes. If it's a number that's short like this, it only goes to the hundredths, then keep it that way. If it's going on forever and ever and ever, I would say rounding it to the hundredths is good protocol for scientific work and things along those lines, or the tenths if you'd like, as we did up here, because that's how we had done the rest of the lessons in this section. But yeah, definitely if you can keep it unrounded, do that, but the tenth or hundredths, either is good. Maybe a little discrepancy in what you get as an answer, but all right, anyways, enough about that. We want to take the square root. We want to get t by itself. So if I take the square root of both sides, it's going to cancel out my squared and my square root symbol. T comes down. The square root of 31.25 is equal to 5.59, on and on and on and on and on. So I'm going to say 6 seconds. So that bolt, from the time it drops out of his hand, that construction worker is all the way to the ground, 6 seconds. That's incredible. Way beyond a football field. No time at all. So, all right, that's today's lesson. If you need any help, come and see me or look it over again, and I'll see you for the next one. Bye, guys.